Well, grade 10s, in this lesson, we're going to be looking at analytical geometry, and we're going to be specifically in this lesson looking at the distance between 2 points. Okay, on the Cartesian plane, the x and the y system here, we want to find the distance between, let's call this point A and call this point B. We want the distance between those 2 points. Okay, the length of the line segment AB. Now, what we've got to do is we've got to do a little bit of mathematics here. Now, what I'm going to do is I'm going to determine the coordinates of A and B at the moment. So we've got 1, 2, 3, 4. That's 0, 1, 2, 3, 4, 5, and 6. Now, the coordinates of A would be 1 and 2. The coordinates of B would be 4 and 6, as you normally did. Now, we want to get the length of AB. Now, what we could do is use Pythagoras. So, let's just indicate this point over here, this corner, as C, and let's get the coordinates of C. Well, what is the coordinates of C? 4 and 2. X is 4, Y is 2. Now, you know, if you look at this triangle, if you look at this diagram, that this length of BC is 4 units, and the length of AC is 1, 2, 3 units. And of course, we could use Pythagoras to get the length of AB there by simply doing this. So you would say, look, AB squared is equal to, if you think about it, it's AB squared is going to be AC squared plus BC squared, which if you work it out is going to give you AC. What's the length of AC? Is 3, and the length of BC is 4. So it's 3 squared plus 4 squared, and then you can easily get the length of AB. 9 plus 16 is 25, and if you square root 25, you get 5 units. Okay, now, the thing is with this, we can indicate that over here. That's the length of AB, and we normally say 5 units. But now I want to develop a wonderful formula now, but before I do it, I need to just clear up a few little things here. Okay, now, watch this. If you have a look at this, I want you to focus on the length of BC for a moment. We know it's 4 units, but I want you to check this out. If you take the y value of B, okay, and you subtract the y value of C. In other words, you take the y value of B and you subtract the y value of C. Makes sense. It's 6 minus 2. That is 6 minus 2, which equals 4. That is the length of that side BC. Do you see? It's the y of the B minus the y of the C. Okay. Now look at this one over here. Okay, if you go to, let's go to pink. Okay, if you have a look at that length there, AC, it's 3 units, but I want you to focus on this. If you take the x of C and the x of A, now watch this, the x of C minus the x of A, what do we get there? Okay, the x of C, now look at it again, there's the x of C minus the x of A. What is that going to give us? It's going to give us the 4 minus the 1, which guess what? Is the 3 units. Now I want you to hold on to these concepts, and I'm going to redo Pythagoras, but I'm going to plug in the red and the pink. So let's have a look at this. So I'm going to remove this Pythagoras story here. Okay, we'll delete that, and I'm going to just tidy this up a little bit here. Now have a look at this. It's brilliant. Okay, what we've got is we can say AB squared, which I'm just going to go to black to make it a little bit more clearer. Okay, have a look at this. AB squared is equal to, now watch this. What is AC? Now AC we know was 3, but we can say the x of C minus the x of A. Alright, it's the x of C minus the x of A. Look again, AC is the x of C minus the x of A, 4 minus 1. That gives you AC. But then what about BC? BC is the y of the y of B minus the y of C, which is 6 minus 2, which is 4. So I want you to look at BC as follows. The y of B minus the y of B minus the y of C, and that's squared if you use this. Now, the distance formula as we know it is going to involve points A and point B. So I'm going to work on all the ones that have got C in it, the x of C. Now look at this. What do you know about the x of C? Now have a look at this. This is important. What do you know about the x of C? The x of C is 4. So the x of C is 4. What do you know? What else is that equal to? The x of C is the same as the x of B. They're both equal to 4. So these guys are the same. The x of C is the x of B. So I'm going to say the x of C is the same as the x of B. Okay, now what about the y of C? Have a look at the y of C. The y of C is 2. But what is the y of A? Is also 2. So look at this. The y of C is equal to 2, and the y of A is equal to 2. So the y of C and the y of A are equal. YC is YA. So that's the y of A. Those two are equal. Now if I rework this formula, now watch this. The length of AB squared is fascinating. It's the x of B, which I'm replacing x of C with here, minus the x of A squared plus the y of B minus the y of A, all squared. Now this is called the distance formula. Now I'm going to show you how brilliant this is. What it's saying is when you've got the point A, B, the point A and the point B, you can get the distance between those 2 points by saying the x of B minus the x of A squared plus the y of B minus the y of A squared. Let's have a look at this. If you look at the point A is the point 1 and 2, and B is the point 4 and 6 from the diagram. Let's have a look at that. We're taking those points out there. There's A and B. Now to get that length, instead of using Pythagoras, we know it's 5. What I'm going to do is I'm going to use this little new formula, and I'm going to say that AB squared is equal to the x of B. Now the x of B is this guy. It's 4. What is the x of A? That's the x of A there. X of B, x of A, which is 1 squared. Notice that's 3. Plus, what is the y of B? The y of B is 6. And what's the y of A? Is 2. Now watch this, people. This is just linking so beautifully to Pythagoras. It's 3 squared plus 4 squared. That's exactly what it is. But the beautiful thing is if you've got 2 points A and B, if you go the x of B minus the x of A, that's 4 minus 1 squared, and then you go the y of B minus the y of A all squared. It comes out to the Pythagoras thing, and AB squared is then 9 plus 16 is 25, and once again AB is 5 units if you square root. So this is called the distance formula. By the way, you could also go the other way. There's no reason why you can't say AB squared is equal to, watch this, you could also say the x of A minus the x of B squared, plus the y of A minus the y of B squared. Look how it works. If you look at AB squared, what is the x of A is 1, minus the x of B is 4, and what is the y of A is 2, and the y of B is 6. Now look at that. Because of the squared, of course, that's nice, because this will give you AB squared is negative 3 squared plus negative 4 squared. No problem. That's going to work out as 9 plus 16, which guess what is 25. And there we have it. It's exactly the same. So it doesn't matter the order that you do it in, as long as the x's are together and the y's are together, and we have what we call the distance formula. So what it's really saying is that if you want the length of that line segment AB, all you do is you say AB squared is equal to the x of B minus the x of A squared plus the y of B minus the y of A squared. You subtract the x's, subtract the y's, you would have squared, and you can easily then work out that length there, which is 5. Comes from Pythagoras. Okay, so let's practice. I'm going to give you some more points, and let's practice an example quickly so that you get really good at this. If I gave you the points here, let's have a look at A. Now you don't even have to draw the diagram. A 1 minus 4 and B is equal to negative 2, negative 7. And I said, what is the length of the line segment AB? What is the distance between those 2 points? No problem. AB squared is the x of b minus the x of a squared, or the x of a minus x of b, plus y of b minus the y of a squared. Now watch this. All you now do is say, what's the x of b? The x of b is negative 2. Now careful. What is the x of a? Is 1. Good. Okay, plus. What's the y of b? Is negative 7. Subtract. What is the y of a? It's negative 4. Keep it in brackets. Squared. It's negative 7 minus negative 4. Here it's negative 2 minus 1. So what is the length of AB squared? Is going to be negative 3 squared plus negative 7 plus 4 squared. So AB squared is going to be 9 plus, what's this? This is negative 7 plus 4 is negative 3. Okay, so that gives you AB squared is equal to 9 plus 9, which of course is 18. So all you now need to really do is square root this, both sides, and length is always positive, so we keep it as that, and that you can work out as a decimal. You can leave it as root 18 units. If you do this in the calculator, you could also see it comes to 3 root 2. Now how that works is root of 18 is actually the square root of 9 times 2. If you square root the 9, you get 3. If you square root the 2, well, it stays like that. So either way, you could also use a calculator to do it, and that gives you the distance formula. Now I want to give you a practice example, and I want you to calculate using the distance formula the value or the length of the line segment joining these 2 points. So here's your practice example, and I want you to have a go at this. The practice example says here, let me get my English right here, and the practice example says, I'm going to give you 2 points here, and the 1 point is A is going to be 6, negative 3, and B is the point negative 4 and 2. I want you to work out the length of the line segment AB, or the distance between those points. Have a go, and then we'll discuss it.